All right, this video is going to be a review for two things. One, it's going to be a review for a situation where you have two objects, and the second one is when, again, we're dealing with an inclined plane here, so we're going to be shifting the axis. A couple things here. We got an angle of 20 degrees, which we know. We do know the masses this time. I've labeled this first mass on the hill, mass 1, and the second mass that is hanging over here off the pulley, mass 2. And we're trying to find the acceleration of the system. Of course, like we talked about before, 1 and 2 are going to accelerate the same amount because they're both going to start at the same velocity, have the same amount of time, and end at the exact same velocity. So they both have the exact same acceleration. Like we talked about in class, first thing you want to do with multiple objects is set a direction for positive. And the easiest way to do that is just the way that you anticipate they're going to go. If they don't go that way, it's no big deal. You can just, you'll just get a negative answer rather than a positive one. So again, we'll just say this is positive. Now let's do the force diagram. Oh, another note real quick. This problem, we're going to say that the hill is frictionless. So a problem on your homework might say this is frictionless, or it might say mu is equal to 0. In which case, I do not suggest you draw the force of friction, because obviously it would be 0, even if you're kind of thinking of it that way. So here we have force gravity, and I'm going to label that as 1. We have force normal. Typically, force friction would be that way if we had it, but obviously there's not in this case. And then there's going to be tension of the hill. For object number 2, we should have force of gravity 2, and tension should be up. And this tension should be smaller than that one because I anticipated accelerating down. If I'm wrong, again, that's fine. The math will work out. It'll know that, and we'll get a negative answer here telling me that I was wrong, but the answer will still be exactly the same. So let's begin over here on the left side. Now, typically what we would do on an S-shift axis, and this is what we're going to do here, I say typically, like we're not going to do this, is draw the x, well, not the xy, but the parallel perpendicular line. Now, notice something that usually happens on a hill is that gravity goes this way, and because of the perpendicular axis, a lot of times force gravity here that's parallel, I guess I'm messing up, is actually positive because it's going with, where in this case over here, this force gravity is going to be negative because it's resisting that particular acceleration. Now, a lot of times on this guy right here, I would sum the forces in the y or the perpendicular because I get force normal. But since we have no friction, we don't really need to do that. So we're just going to go ahead and straight sum the forces parallel, or in the x equals mass times acceleration. And if I look at my force diagram, normal has none, tension is positive, and it's all there, so positive force tension. And force gravity has this little bit right here, and is negative. So we're going to say negative force gravity parallel, and that's equal to mass times acceleration. That is parallel. Okay, and I don't know force tension. I would calculate force gravity parallel with trig. This just shifted right here by 20 degrees, so you'll notice this side is the opposite. So this is going to be mg sine of that angle. And if I look through this whole thing, ft I don't know, mi I do know. Ooh, I made a mistake here. Actually, I should be focusing on the fact that this is actually the first. That is the first mass, and that's the first mass, and that's the first mass. I didn't put my subscripts on there like I'm supposed to. Next, let's go over, and I have two unknowns. I don't know tension, I don't know the acceleration, so we're going to go ahead and go to the other object. And that would be summing the forces in the y, as mass times acceleration in the y for object number 2. And that would be this guy right here. So normally force gravity would be negative, but since we made that positive, we're going to have positive force gravity on 2 minus force tension, and that's it, equals m2a. And actually, let's go back here and erase the parallel on this guy, because that's all acceleration 2 as well. And force gravity 2 is just going to be m2g minus ft equals m2a. And now I've got my two equations, two unknowns. As we discussed in class, you could use substitution or elimination, but elimination is certainly easier here because the FTs are going to cancel. So I'm going to take that side and add them together. Why did I start with the 1 on the right? Because this is a positive number right here. There's really no reason you can do whatever you want. And then the 1 on the left right here is positive force tension minus m1g sine theta. And now we're going to add the left and right sides together, m1a plus m2a. Let's go ahead and cancel, and factor out a over here. And then divide underneath, and you get m2g minus m1g sine theta over m1 plus m2 equals a. And now we should plug our numbers in. See, m2 was 4 kilograms times g minus 3 kilograms times g times the sine of 20 degrees all over 3 kilograms. I think I did that in the wrong order. No, that's right. Plus 4 kilograms. And if you plug this into your calculator, you get an acceleration of 4.16 meters per second squared. And that's how you do that.